Alrighty, as promised, we are back today with factoring day 2. We are going to look at first two special types of binomials. Again, binomial just means you have two terms in your polynomial, and that is sum and difference of two cubes. So if I have two perfect cubes being added or subtracted, I can factor them out using these two formulas. So whatever the cube root of a cubed and whatever the cube root of b cubed are will tell you what a and b will be for whichever expression you're factoring. And if it's sum of cubes, you will have a plus b times a squared minus ab plus b squared. And if you have a difference of two cubes, you have a minus b times a squared plus ab plus b squared. Now these formulas are very similar. You'll need to memorize them. And if you'll notice, the terms are all the same. A, b, a squared, ab, b squared. What changes is where you have an addition or subtraction and an addition or a subtraction. In the first two, they switch if you have sum or difference. And then just like our difference of squares, it's very easy to factor these. The tricky part comes with recognizing that that's what you're supposed to do. So memorizing some perfect cubes, I would recommend up to 7 cubed is going to be the easiest way to recognize that that is the next step. So we're going to get into some examples here with factoring. Starting with x cubed plus 8. For this one, a is going to be x, and b is 2. So using my sum of cubes, because these are being added, that will give me x plus 2, a plus b, times a squared. If I square x, that gives me x squared, minus a times b, x times 2 is 2x, plus b squared. If I square 2, I get 4. And just like all of our other factoring methods, you could multiply this back out to make sure that you factored correctly. Just note that for this kind, where you have a binomial and a trinomial, you'll need to do multiplication 6 times and combine like terms. Okay, on to my next one. I have 27y to the third plus 8. A for this one is going to be 3y, and b is 2. So again, sum of cubes, so I'm going to do a plus b, 3y plus 2, times a squared. Now remember, when you're squaring something, that means you're multiplying it by itself. So if I'm squaring 3y, that means it's 3y times 3y. So 3 times 3 is going to give me 9. Y times y is going to give me y squared. So when you square 3y, you get 9y squared. A mistake people will often make is they forget to square the coefficient as well. So don't make that mistake. 9y squared, and then minus a times b. 3y times 2 is 6y. Plus b squared. Once again, 2 squared is 4. All right, 216 x cubed minus 125 y cubed. A is going to give us 6x this time, and b is 5y. So again, using my sum of cubes formula, a plus b, 6x plus 5y, times a squared. Remember, I'm squaring the 6 and the x, 36x squared, minus a times b, 6x times 5y is 30xy, and then plus, I'm going to have to squeeze this in here real tight, b squared. 5y squared is going to be 25y squared. Just barely squeezing that in there. 25y squared. All right, on to my next row. I have 8x cubed minus 64, so a is going to be 2x, and b is 4. So this one is subtraction now. Oh, and I made a mistake on that previous one. I missed that it was subtraction, so I need to switch these two signs. This should be minus, and this one should be plus. My apologies. Minus plus plus when it is subtraction. So back to difference here. 2x minus 4 times, if I square 2x, that gives me 4x squared, plus 2x times 4 is 8x, plus 4 squared is 16. Now, looking here, I have a GCF I can take out from 2x and minus 4, and that is 2. And that will give me x minus 2. And then in my second one, 4x squared plus 8x plus 16, there's a GCF of 4 that I can take out, and that will leave me with x squared plus 2x plus 4. So bringing these two coefficients to the front, I have 8x minus 2 x squared plus 2x plus 4, and that is my final result. Now, if I had recognized from the start these two terms, 8x to the third and 64, have a common factor of 8, I could take that out from the start, and then I would not have to do this middle step. But even if you miss it, you need to make sure that if you end up with common factors that you factor completely. Okay, on to our next one. A for this one is going to be y squared, because if I cube y squared, that gives me y to the 6th, and B is 4n squared. So this is subtraction, so difference of cubes, y squared minus 4n squared times, if I square y squared, that's y to the 4th, plus y squared times 4n squared y squared, plus, if I square 4n squared, that is going to give me 16n to the 4th. And then if I look very closely, my first parentheses now, this is a difference of two squares, which factors to a minus b times a plus b. So for that one, a would be y, and b is 2n. So my first parentheses, I can expand further, y minus 2n, y plus 2n. And then that second parentheses from our first factorization just becomes your caboose at the end. It doesn't go away. It is part of your final answer. So this whole thing is our final result. Okay, last one. I have k to the 9th, and k to the 9th. Let's change that to another letter, like, say, j, because that's what it's meant to be, two separate letters. So, again, I have a sum of two perfect cubes. So a will be k to the 3rd, b will be j to the 3rd. So using my sum of cubes, that's k to the 3rd plus j to the 3rd times k to the 6th minus k cubed j cubed plus k to the, sorry, not k, j to the 6th. And if I look very closely, I now have another sum of cubes here in the front where now a is k and b is j. So I can expand this first factor further, and that will give us k plus j times k squared minus kj plus j squared. And I still need that final caboose all at the very end. And I'm not really going to be able to squeeze all of that in here. I'm going to do my best. K cubed plus j cubed plus j to the 6th. That whole thing is part of my answer. So that is your sum and difference of cubes. Next, we're going to talk about greatest common factor. So when you have more than one term and you're looking for a common factor, you are going to look at your coefficients. What is the greatest integer that divides each coefficient? And you're going to look at your variables. And if they all have a common variable, you can only take out the lowest power. Power is just referring to the exponent. And so you can only take out the smallest power. So we're going to look at that here first, starting with 16y squared minus 24y. Between 16 and 24, my greatest integer that divides them both is 8. And they both do have a y. I have y squared and y to the 1. The lowest power is just y to the 1, so that's all I'm going to be able to take out is 8y. If I divide 16y squared by 8y, that leaves me with 2y. And if I divide minus 24y by 8y, I am left with negative 3. And just like all of our other factorizations, you could distribute that back out to make sure you get what you started with and check that you have factored correctly. On to our middle one, between 12 and 28, my greatest integer that divides them both is 4. They do both have an x. The lowest power is x to the 1. And they both do have a y. The lowest power is y to the 1. So I can take out 4xy, and that will leave me with 3x plus 7y. Again, distribute back out to make sure you factored correctly. On to our last one for this row. I have negative 8, negative 6, and 4. So between 8, 6, and 4, I know I can take out a 2. And when your leading coefficient is negative, I'm going to recommend that you factor out a negative as well to turn it positive. So I'm going to factor out a negative 2. And now if I'm looking at my three terms, they do not all have an a. This last one does not have a, so I can't factor it out. But they do all have a b, and the lowest power is b to the 1. So I'm going to be able to take out a negative 2b, and that will leave me with 4a plus 3ab minus 2. And again, you can distribute that back out to make sure that when you multiply negative 2b by all three of those terms, you would get what you started with. All right, last one for this side, the area of a rectangle of width w. So the width of my rectangle is w. If the area is 32w minus w squared, that's my area. Factor this expression to determine the length of the rectangle. Well, if I look at this expression, it is a binomial, so I can't use my x method. I don't have perfect squares on both. W squared is a perfect square, but 32w is not. I don't have perfect cubes, so the only thing I'm going to be able to do is take out a common factor, and between both of these, they have a w. So if I take out a w, that will leave me with 32 minus w. Now, why does that matter? Well, when you're looking at the area of a rectangle, that is length times width. And I already know that my width is w, so the other factor, 32 minus minus w, must be my length. So the length is 32 minus w. So what this tells me is, say, if my width was 5, then I would know that my length would be 32 minus 5, which in this case is 27. But again, factoring this out, and I know this has to be length times width, they told me my width was w, so the other factor is my length. I'm going to get cut off on time, so I'm going to do the back page in a second part.